Okay, in this problem we're asked to find the 100th term and the nth term for the following sequences. Okay, so we're given these sequences here, but we're not told whether or not they're arithmetic sequences or geometric sequences. So we're going to have to figure that out on our own first. Okay, and a quick reminder on what each of those are. An arithmetic sequence, you add a common difference d to get the next term. The common difference can be found by subtracting any two successive terms in the sequence. So like on this first problem, 9 minus 1 gives you 8. 17 minus 9 gives you 8. 25 minus 17 gives you 8. That means this first one is geometric. Or excuse me, this first one is arithmetic. Okay. And a geometric sequence can be found, well, it's the sequence is when you multiply the common ratio to get the next term. Okay, and the common ratio can be found by dividing any two successive terms in the sequence. Now you should get the same answer every time. Okay, so an example of this would be this one here. What's 5 divided by 1? 5. What's 25 divided by 5? 5. Okay, and you would keep going. The next one would be 125, and that would be 125 divided by 25, also 5. So this one is geometric. Okay, so what about the other ones? Okay, so we take a look at B, and it's hard to tell sometimes just by glancing at it, but if you do the subtraction, which is usually the easiest thing to do in your head, 160 minus 90 is 70. 230 minus 160 is also 70. So it looks like that's going to be arithmetic. Okay, if you try to divide 160 by 90, you're not going to get the same thing as you would get if you did 230 divided by 160. So it's not geometric. Okay, so this one is also arithmetic. Okay, what about this one here? Okay, so 6 to the 6th, 6 to the 11th, 6 to the 16th. Okay, so that doesn't look like you're adding the same thing each time, because by the time you get over to 6 to the 11th, 6 to the 16, those numbers are getting huge, whereas the difference between 6 and 6 to the 6 is not as big, but the difference is way bigger between these two terms. Okay, so it's probably going to be geometric, but in order to figure that out, you would want to divide some terms. So if you did 6 to the 6th divided by 6 to the 1, that gives you 6 to the 5th. Okay, subtract the exponents there. Okay, let me zoom in on that for just a second. Okay, and let's do another one just to make sure. Let's do 6 to the 11th divided by 6 to the 6th. 11 minus 6 is 5, so it's also 6 to the 5th. So this is geometric. Okay, zoom back out here. All right, and for E, okay, this one is going to be the hardest one to see. You got to look for what is changing each time, because it looks like each one of them has a 50. Okay, so that doesn't change. Each one of them has a 5 to the 15. And the 8, the 9, the 10, that's what's changing. Okay, so what this is saying is that you have 50 plus 8 of the 5 to the 15s. The next term, you have 50 plus 9 of the 5 to the 15s. The next term, you have 50 plus 10 of the 5 to the 15s. So you're getting one extra 5 to the 15 extra every time. Okay, so that's adding one extra 5 to the 15 each time. Okay, so this is also going to be arithmetic. All right, so now that we've got that established and we've got our formulas here, you can reference those. I'll pull them up a couple more times as we go. Let's take a look at the first one. Okay, so we have 1, 9, 17, 25, ... And we've already said that it's arithmetic, which means we're going to be using a sub n equals a sub 1 plus n minus 1 times d. Okay, so we found the common difference. Whoops. We find the common difference by subtracting, and we already talked about this earlier. 9 minus 8 is 8. 17 minus 9 is 8. 25 minus 17 is 8. So d is equal to 8. And what is a sub 1? Well, a sub 1 is just your first term. So a sub 1 is equal to 1. So now we know that our sequence is a sub n equals 1 plus n minus 1 times 8. Clean that up and you get 1 plus 8n minus 8 equals 8n minus 7. That is your nth term. Okay, so we found the nth term first. Even though it said find the 100th term first, it's easier to find the nth term first. Because now all we have to do to find the 100th term is write a 100 in place of n. So 8 times 100 minus 7. Okay, so that's 800 minus 7, which will give us, 793. Okay, so that's the first one. Let's move on to the second one. Okay, so on this one we have 90, 160, 230, and so on and so forth. We've already said that this is arithmetic. Okay, and we already talked about the difference. We said it was 70, right? Because 160 minus 90 is 70. 230 minus 160 is 70. So we can say that D is equal to 70. We can also say that A sub 1 is equal to 90. So we write that down. A sub n is equal to 90 plus n minus 1 times 70. Okay, and if we clean that up a little bit, we get 90 plus 70 n minus 70. And then that gives us 70 n plus 20. And if we want to find the 100th term, we plug in 100 and we get 70 times 100 plus 20. Okay, and that looks like that gives us 7,020. Okay, let's take a look at the next one. We've got we said that this one was geometric. Okay, so we've got 1, 5, 25. The next one would be, if you followed that pattern, would be 125, and so on. Okay, and since it's geometric, we know we need to find the common ratio. We need to know what R is. Okay, so we already talked about this again earlier, but R can be found by dividing any two successive terms, so 5. And if you want to make sure, divide another one. 25 divided by 5 also gives you 5. 125 divided by 25 also gives you 5. So that's the common ratio there. Okay, and we also said that we need to use a formula. Since it is a geometric, we'll use the formula A sub n is equal to A sub 1 times R to the n minus 1 power. Okay, so A sub n is equal to 1 times R. Excuse me, I shouldn't have wrote R, I should have wrote 5. So 1 times, let me write that again. A sub n is equal to 1 times 5 in place of R to the n minus 1, which is just going to be 5 to the n minus 1 power. That's your nth term. Okay, plug in a 100 for your 100th term equals 5 to the 100 minus 1 equals 5 to the 99. And that's your 100th term. Okay. All right, let's do the next one, which is 6, 6 to the 6th, 6 to the 11, 6 to the 16, and so on. Okay, we already said that this is geometric. We found the R by dividing any two successive terms. 6 to the 6th over 6 is equal to 6 to the 5th. And we did earlier, we tried this too. It also came out as 6 to the 5th. Okay, using the same formula that we did before, we have A sub n is equal to A sub 1 times R to the n minus 1. So A sub n is equal to 6 times 6 to the 5th to the power of n minus 1. Okay, so this is actually the nth term, but it doesn't really look good, so we want to clean that up a little bit. First thing I'm going to do is distribute this 5 to the n minus 1. Okay, so that'll give me 6 times 6 to the 5n minus 1. Or actually 5n minus 5, excuse me. 5 to n and then 5 to the negative 1. So 5n minus 5. Okay, let me write that again. 6 times 6 to the 5n minus 5. Okay. And then if we have this 6 to the 1 power, and we have 6 to the 5n minus 5 power, you add those. So it'll be 6 to the 5n minus 5 plus the 1 that we have from here, which gives us 6 to the 5n minus 4. That's your nth term. If you want the 100th term, you do 6 to the 5 times 100 minus 4. So that's 6 to the 500 minus 4, which is 6 to the 496. Okay. And then for the last one, okay, so we've got this one that we did say that this was arithmetic. Okay, so we have, there's an extra term being added in each one of those, an extra 5 to the 15th. So it was a little difficult to find that common difference. But what we said is that if we have 50 plus 8 times 5 to the 15, which is your first term, what I'm positing is if we add a 5 to the 15, if we're saying that's our common difference, will we get the next term? Okay, if we add 5 to the 15. Well, right now we have 8 of them. 8 of the 5 to the 15s plus another 5 to the 15 is equal to 50 plus 9 times 5 to the 15. Okay, so that gives us our next term. So if we add this term, we'll get our next one. If we added it again to this one, the 50 would stay the same, and instead of 9 of the 5 to 15s, we would have 10 of the 5 to the 15s. Okay, so a little different strategy on finding the common difference there, but our common difference, D, is equal to 5 to the 15 power. Okay, and looking at our formula again, we have, let's write it down real quick, a sub 1 plus n minus 1 times d. Okay, so we have a sub n is equal to, our first term is all this stuff here, so 50 plus 8 times 5 to the 15, that's our first term, plus n minus 1 times d, which is 5 to the 15. Okay, so we're going to have to clean this up a little bit. Okay, so we clean this up a little bit, we distribute this to here, so a sub n is equal to 50 plus 8 times 5 to the 15, plus n times 5 to the 15, minus 1 times 5 to the 15. Okay, so we can immediately combine these two terms, right? We have 8 of the 5/15s minus 1 of the 5/15s. That gives us 7. So 50 plus 7 times 5 to the 15 plus n times 5 to the 15. Now, how do we take care of these? Because this is not a number, so we can't readily combine it. But we can factor out a 5 to the 15 out of both of these since they both have it in there. So we can take a 5 to the 15 out and put it out front. So plus, here's the 5 to the 15 that's coming out front. What does that leave on the inside? Well, if this one, the 5 to 15 goes away, that's a 7. And if this one goes away, that's an n. So I'll write n plus 7. 7 plus n, either way. Okay, so this is the nth term. 50 plus 5 to the 15 times n plus 7. Now, if we want to find the 100th term, 50 plus 5 to the 15, I'm going to save myself and just say some time and just say 107 because I'm plugging in 100 there. Okay, and I'm just going to leave it just like that. Not going to try to clean that up any because those numbers are enormous, so there's no use really trying to mess with it. And that's it.